Hello. Along with my co-authors, Sam and Katya, I'm excited to give you a glimpse today of our paper, presenting challenges and opportunities for creating agents in commercial games. Agents in commercial games are commonly created using finite state machines, behavior trees, utility systems, or planners. Recently, we have seen the potential of game-playing agents created using deep reinforcement learning and imitation learning in various challenging commercial games. This video is a recent example that shows a team of agents trained using deep reinforcement learning coordinating to play the team-based arena shooter Bleeding Edge. You can see the different characters playing together to take down the opposition. A big shout out to Project AIIDE, which is a research collaboration between Microsoft Research and Ninja Theory to explore the potential for deep reinforcement learning in commercial games. You can find more information about the research at the link above. As deep RL gains recognition within the games industry, researchers can drive its adoption by understanding what industry challenges it could best address. Conversely, the unique requirements of commercial games provide RL researchers the opportunity to understand where the technology and workflows for using it need to mature before it can be adopted more broadly. In our paper, we present a research study that aims to illuminate these challenges and opportunities as a foundation for shared progress between researchers and industry practitioners. Our research questions for this study were as follows. What opportunities exist for AI researchers to support commercial game agent creation? What practical challenges must researchers solve to build RL agents for commercial games at scale? In order to answer these research questions, we used the following methodology. During our study, we collected data in the form of semi-structured interviews from 17 participants representing a spectrum of the game industry. The participants worked with AAA studios, indie studios, or industrial research labs that experimented with RL for creating game agents in commercial games. We used a qualitative methodology with a small sample size instead of large-scale surveys in order to elicit open-ended and richly detailed responses that could feasibly be analyzed by our research team. Our semi-structured interviews collected data about participant workflows, their challenges experienced, what tools were used or desired, as well as any concerns or opportunities they saw for ML in their previous projects or current workflows. However, this paper focuses on a subset of our data related to challenges experienced by game agent creators. Data collection was followed by thematic analysis, where participant responses were transcribed, iteratively coded for key concepts, and hierarchically developed into themes. These themes organized the challenges experienced by the game agent creators at various stages of the game agent creation pipeline. The figure on screen shows the resulting themes relating to challenges experienced by these creators that were surfaced by our analysis. The themes highlighted in color are featured in our paper. For more detail and a synthesis of these challenges with prior research resulting in several proposed opportunities for supporting game agent creation in commercial games, please see our paper. The first theme I would like to discuss related to challenges experienced while designing the agents. Several designers remarked about the challenge of trading designer control for stronger agent autonomy, especially if they needed to repeatedly get engineering support to shape agent behaviors. Other designers spoke about the challenge of creating compelling bots for players in a range of skill levels. Behavioral readability, or the degree to which an agent could communicate its decision-making to players through its actions, was another challenge raised. A challenge more specific to RL was that rapid ideation and design exploration was stifled by the task-oriented nature of RL training workflows. Finally, the tension between authorial control and agent autonomy signaled a potential shift needed in design philosophy around these games. The next set of challenges related to the actual implementation and iteration of agents. Several RL engineers reported the necessity of early planning and adaptation of their existing agent creation workflows to handle the training times needed for sample-inefficient RL training. RL engineers also reported that they needed to significantly scale up their RL training infrastructure, adding parallel experimentation, fault tolerance, and performance monitoring to handle the complex commercial games that would often crash experiments due to bugs in the work-in-progress games. Other RL AI engineers raised the need and challenge of rapidly adapting existing agents to new contexts for agent creation at massive scale. Finally, engineers working with AI systems, driven by lots of numeric parameters, noted the tedious, inefficient, and uncertain nature of parameter tuning that often prove challenging to achieve specific qualitative improvements in agent behaviors. The final set of challenges presented in this talk related to evaluating game agents. RL engineers who were evaluating their agents using task-specific criteria such as KD ratios or damage dealt and measures of human likeness recognized a need for measuring the player's experience of playing against these agents, as well as the need to respect compute budgets when integrated into production games. There was also a broad demand for automating agent testing in order to free up creator resources and scale up the QA coverage of agent performance. Several engineers raised the challenge of more objectively understanding their agent's performance in the game, moving beyond the narrowly specific metrics and broadly subjective qualitative evaluations they were using. Finally, several RL creators found it challenging to interpret RL training graphs for predicting eventual agent behaviors or player experiences with the agents. Many potential opportunities for impacting the game industry, as well as improving the underlying AI technologies, surfaced from my analysis when evaluating specific challenges against prior research. A small sample from each theme follows. There is a real opportunity to develop novel algorithms and systems that facilitate trading off authorial control and agent autonomy. However, there is also an opportunity to better understand how to design game experiences featuring strongly autonomous agents such as those created with RL. Instead of requiring precise control over character interactions, designers could instead seed the environment with specific kinds of autonomous agents and environmental systems or props in order to facilitate or control the odds of specific kinds of interesting player interactions with these agents occurring. There is also a key opportunity for automating the adaptation of game agents between similar situations in the game so that creators don't need to create agents from scratch each time, or to use special case scripting to improvise their own solution. Generalization and transfer are both known challenges for RL, and this provides a clear use case for applying advances in this area. A final key opportunity is to apply techniques like RL and imitation learning to automate game testing for scenarios where traditional automation techniques struggle. I would like to conclude by encouraging anyone interested in finding out about all the other meaty challenges and exciting opportunities from our study, as well as how they connect to current research, to read our paper for more information. Thank you for your attention. I look forward to answering your questions during the talk and look forward to seeing you at the panel.